So welcome back to Fermi Physics Solutions. This is the concept explainer video part 4, looking to give an understanding of Ohm's law in a circuit. So what Ohm's law does is it relates the current traveling through a circuit to the potential difference that you put across a circuit. And the general gist is sometimes this kind of phrased as an investigation, where you would ask somebody, well, what is the variation of current across a circuit as you increase the potential difference? And Ohm's law is a nice little investigation that you can use to look at that. There's many different setups, and I will make a video at some point going through what I would use in a lab to go through the actual equipment and what I find to be the easiest way to set the lab up, in order for students to actually get those resistance values or the current values or the potential difference values across their circuit. But for the diagram, I'm going to show you a really simple version that you can do if you have the equipment as well. And the nice thing about this is, apart from maybe the batteries, you can pick everything else up just with your standard lab kit out, and the batteries can be found in, a Centra or Tesco's or Dunnes Stores, Aldi, Lidl, whichever one you have around you. So it's a nice easy setup to do. So first of all, just we set up a simple circuit, and the simple circuit is got one resistor and one battery, and we form a closed circuit as shown. So what we'll do is we'll have a quick look at the charges moving around the circuit. And again, so we take a snapshot and we can see that as the charges are flowing for this particular circuit, at the very center point of this loop, there is 1 coulomb passing per second, which means it has a current of 1 amp. So if I were to replace that with an ammeter and place an ammeter there, I would see that if I'm using a battery which is 1 volt, and I'm using a resistor which is 1 ohm, then I end up getting a current of 1 amp passing at that point. So what this tells me is that for this particular resistance, with this particular potential difference, I have 1 amp of current passing around that circuit. So that's 1 amp leaving the positive terminal, going down through the ammeter, going through the resistor, going through the wire, back up towards the negative terminal, and 1 amp again going through the battery, and that's going to form the closed anti-clockwise loop which we've seen before. If I look at this in terms of the formula, I know that V is equal to IR, and I know that my circuit has an overall resistance of 1 ohm. How do I know that? Because I'm after picking the resistor from my lab, and I put a 1 ohm one into the circuit. I also know in this case I've only used 1 battery, and the batteries I'm happen to using only have 1 volt potential difference. So 1 volt is equal to whatever my current is multiplied by 1 ohm. So I need to think to myself, well, what number do I need to multiply 1 ohm by to get the 1 volt? So blank multiplied by 1 gives me 1. What's my number for blank? That means I have 1 amp. So that's a nice way just to show what the calculations are doing. Then what I do is I replace my battery with 2 batteries. Now, in doing so, I have now added more potential difference to the circuit. What I haven't changed is the resistance. The overall resistance is still the same, but my potential difference has gone up. And what we can see now is that by putting more potential difference into the circuit, I'm after increasing my current. So the resistance stayed the same, the potential difference went up, so something has to go up in order to balance that out. And in this case, it's the current drawn, and that flows through the whole circuit. So in this case, if I look at my loop here, at the very center point of that loop, there's 2 coulombs passing that point per second, which, as we know, is 2 amps of current. So the overall potential difference of the batteries is 2 volts when you set them up in series like this. So 2 volts is my overall potential difference, but my overall resistance is still 1 ohm. So again, I think I'm increasing my potential difference. My resistance stays the same. How does the circuit have to balance off the increase in potential difference? And it increases it by increasing the current. Again, looking at the formula, very nice and easy and simple. V is equal to IR. Again, I picked my resistor off the shelf in my lab, so that means I know I have a 1 ohm resistor. I also know that I'm the one who put the 2 batteries into the circuit, so I know that that's my 2 volts. And again, 2 volts is equal to some number multiplied by 1. So I need to ask myself, what number do you need to multiply by 1 to get you 2? That blank number will be 2. So in order to balance out the circuit off, a 1 ohm resistance circuit with a 2 volts going across it will need to balance off that increase by increasing the current to 2 amps as well. I can do the exact same thing again by putting in a third battery. And the third battery, since they're 1 volt each, is going to increase my voltage to 3 volts. 3 volts is going to act across 1 ohm. And again, if I go back and look at the diagram, if I look at the current that's being drawn, I can see at the center point of this loop, there is now 3 coulombs per charge passing. So that tells me when I increase my potential difference, but I use the same resistance, my current has to go up in order to balance out the change in the circuit. So 3 volts will produce 3 amps of current in a 1 ohm resistance circuit. And again, what's that look like with the numbers? Well, again, V is equal to IR. Again, I'm thinking I chose the resistor. I chose a 1 amp or 1 ohm resistor to go into my circuit. I chose to put in 3 batteries, which brings it up to 3 volts. So I've increased the potential difference, but I haven't increased the resistance. And the circuit needs to make some change to balance it off. And it balances off by increasing the current to 3 amps. So that's the gist of what you can do with Ohm's law. And with those circuits, if you really are stuck for kind of complex equipment, you can just put 1, 2, 3, 4, and 5 batteries in series with each other, and that will actually give you your increase in potential difference every time as well. You just need to make sure you have a nice little holder that connects the batteries to the wires easy. It doesn't matter what type of resistor you do, but that will change the current that you get. So in this particular case, if I use a 1 volt battery with a 1 ohm resistor, well, I know from my formula on the last page, when I multiply my resistance by my current, I need to get my potential difference. So 1 ohm multiplied by 1 amp will bring me back to the 1 volt. However, if I use a 1 volt battery against a 100 ohm resistor, again, whatever the current is, it needs to multiply by 100 to give me 1. So 100 multiplies by 0.01 amps to give me 1 volt. So what we can see here is very simply that when you increase the resistance, your current is going to drop, which we addressed in a previous video so far. So changing a resistor will also change the current in this particular case. And if I were to put a second battery into each circuit, I would get the same sort of changes again. So with 2 volts going over a 1 ohm resistor, I'm going to get 2 amps. But if I put 2 volts over a 100 ohm resistor, I am still going to double my output current, but it's still going to be smaller compared to the diagram on the left because it's a 100 ohm resistor. So now my current is 0.02 amps, and that would balance off with the 100 ohms to give me a 2 volt potential difference. This works again if I increase and put 3 batteries into the circuit, although I admit that diagram does not show that on the right hand side. Obviously that was just an edit error. So when I put 3 volts in there, that's going to give me on the left hand side 3 volts with the 1 ohm resistor will give me 3 amps. On the right hand side, as you can see by the label, 3 volts with a 100 ohm resistor will give me 0.03 amps. What this tells us is when we do our graph, our data, and this is just a sketch of the result, we always get this straight line graph through the origin, which is what we call a directly proportional relationship. Directly proportional is actually quite an easy idea to understand. So let's just say I pick the value for current and potential difference at 1 volt. So let's just say I have a random resistor, and that resistor, when I have 1 volt battery in its circuit, it'll produce 5 amps of current. Directly proportional means this: when I double my potential difference, my output current will also double. So by doubling my potential difference by going from 1 to 2 volts, I also double my current, which goes from 5 to 10. So all you have to do is multiply 1 by 2 to get this value, and if you multiply 5 by 2, it gives you this value. Directly proportional just means that by whatever factor you multiply your potential difference by, you multiply the current by the same factor, and that will tell you what your outputs are going to be. For instance, again, if I quadruple my potential difference, that just means I'm going to quadruple my current as well. So 4 times 1 is 4 volts. So that means if I quadruple my current, 4 times 5 is 20 amps as well. So again, I just multiplied my potential difference by 4, or I put in 4 batteries. That means I have 4 times the current. It even works when you scale down. If I half my potential difference, so if I replace the battery with one that has got half its voltage, that means I'm just going to end up with half my current. And that's all potential difference, or that's all directly proportional, really means whatever change you make to one, you're going to make the exact same change to the other in terms of multiplying up or multiplying down.